Hello, everybody. This is not a container talk, a disclaimer again. We are going to talk about software architecture, architecting distributed applications. And I will show you two patterns that just have a name that is orchestrating, and it always throws conference like, oh, containers. Yes, read the abstract, please. So I hope you all read the abstract. And you're here for the right reasons. I'm Marcia. I work for Amazon Web Services, AWS. I'm a serverless fan. I've been doing serverless since its early beginnings in 2016, when the term serverless was coined, a little bit around that time. And if you want to know more about serverless, you can check my YouTube channel. There is over 400 videos on this topic, hands-on tutorials. And if you have any questions, and I cannot answer them today because you have to run to the next session, reach out on social media, LinkedIn or Twitter, and more than happy to answer anything. And if not, in the corridor, I will stay here the next 2 days. So, the agenda for today, I want to start with 3 challenges. 3 challenges that distributed applications have. The first one is how to coordinate tasks. Then we are going to talk about how to decouple microservices and how to handle errors. And at the end, I want to show you an example application that will put everything that we talk on a real working application. So, first problem, how to coordinate tasks. And this is quite a normal problem when we are thinking about building applications. So sometimes we need to build these applications that maybe are calling some third-party app, or imagine that you're a booking service and you're just in the middle of a lot of different APIs. So you have to call to book a hotel, to book a car, to book a flight, how you're handling those coordinations and those tasks, how you do it properly. We have this principle that has been there for a million years, the single responsibility principle, and it's a very useful principle that I like a lot. And it always applies to the level of abstraction that you're working on. If it's a function, you want the function to do one thing only and in the level of function. If you have a microservice, you want that microservice to do one thing only in general, in the level of microservice, and so on and so forth. And this principle applies very well when you are designing this type of applications, because it makes reusable components, reusable methods, reusable functions easier to test. You know, you love this principle if you have been in development for long enough. So going back to the booking example, you want to build this booking application. You're just a middle person just calling APIs, and you want to have a software that books a trip, a full trip. And if you cannot book one of these parts of the trips, you need to roll back everything. So how we do that? Well, if Marcia of the past 20 years ago, when I started coding, will do this, how it will go is I will make a very, very big method. I will follow the solid principle, not there, everywhere else, but I will make a very big method that will say, book hotel. If hotel booking successful, book car. If booking car successful, book flight, or whatever order it goes. If something fails, then revert it. All those functions will be very solid. My big function will be a mess to test. It will be hard to decouple, because if I want to change one of these functions, I have to redeploy my whole application. I will have to scale things all together. And, well, it's a little messy. You have all built these ones, I'm pretty sure. Then maybe 10 years later, I learned functional programming. And you learn, oh yes, functions should not have a side effects. So now you have these individual functions that call other functions and do things. And this is great. This is easy to test, because now you have these very modular functions. But where is the state? Where I can keep track on what is the status of my booking. And then you have to do some weird hacks, because sometimes we don't know how functional programming works, and it becomes a mess again. Then Marcia, 5 years ago, learned event-driven architectures and say, hey, let's use events. Now we have these functions. They are functional itself because they follow this principle. They don't have side effects. And when they're ready, they just send an event. And yes, that's great. Everything is easy to test. Everything is decoupled. We are happy. But still, the state is hard to know. What is the state of my application? It's distributed around all these different events. And that's okay for many cases. I love event-driven architectures, and we are going to talk about it later. But in some cases, we need some kind of task coordination. We still need that kind of concept of state that we need to manage. Sometimes we need to orchestrate task A and B and then C and have this order, and you don't want to break that order for anything in the world. You have to have a transaction. Sometimes you want to retry failed task, and you don't want to have that logic built in inside your task. You want that logic to happen automatically when something fails. Or sometimes you just need to have this lovely concept of try, catch, and finally, to close connections or to finalize an operation that failed but needs to always run. Sometimes you need to apply the same function to all the items on an array. How do you do that with states, with events? Well, you can do it, but it's hard. Sometimes you want to do something based on the output of something else. If the system A returns something in the variable, we go to B. If it returns nothing, it goes to C. Typical choice or switch. Sometimes we want to run things in parallel. That's good. So these task coordination problems emerge and have a solution in a pattern that is called orchestration. Orchestration is like this orchestra director that is telling every service what to do. Now you violins do this, and now you cellos do that. And everybody's following the instructions, and the orchestra director is the one having the state. So you might be thinking, Marcia, we are going back to that first big function that you mentioned at the beginning. And I was like, kind of. Instead of building that big old function yourself, what you can do is build a state machine. Nowadays, we have many solutions to build state machines. You can use libraries, you can use services, you can use open source. So it's something that is already built for you. And if you don't remember from your early child computing classes, a state machine is a set of discrete states. And we love discrete states in computer science because they adhere quite well to the solid principle. You have a state that does one thing and one thing only, and you can divide it into that level. And then you have an active, as initial state, and active states. It can be a parallel execution, so there can be many active states. And those states are black boxes. They have inputs and outputs. And those black boxes can be replaced while they adhere to the input and the outputs. And then the transitions of those states, what happens is, well, they are based on rules that you define in your state machine. So you can have a switch, you can have a map, you can have parallelization, you can have retries. You define those rules when you are defining your state machine. And also, they can be defined, those transitions, based on the output. If this variable is A, go here. If this variable is B, go here. If you're in the AWS ecosystem, you might know step functions. Step functions is our fully managed state machines on AWS. You can define the state machines. You can have these workflows. You can combine automation with manual work. These workflows can live for 1 year. They allow you to build all the error handling inside. They have integrations with over 200 AWS services, really like first-level integrations. You can integrate your own applications as well. And they have, my favorite thing, a very auditable state. So you can see what happens, the inputs and outputs for each of the states. So it's very easy to debug. So if you want to define these state machines, you can define them as infrastructure as code, basic JSON, call Amazon State Language, or you can use CDK, the Cloud Development Kit, and build it in your favorite programming language. You can also do it visually from the console. I will show you that in a second. You can visualize those state machines either in the AWS console or in your favorite IDE. We have plugins for that, so you can see as you type that JSON how the state machine goes. And that's very important because humans are very visual persons. It makes so much sense when you type code and you can see the actual state machine represented there. And then when you execute it, if you go to the console, you can see how the flow of the events are, how long every state took to execute, how were the inputs, how were the outputs, how was the result of the whole processing. So this is a workflow studio. I think is one of the neatest consoles we have in AWS, where you can define your state machine. So you will see in one side you have all the actions that you can throw. There are over 9,000 of them. These are APIs from AWS. You can search. And then you also have the flow states, that these are like your switches, your parallel, your maps, and whatever you can add there, so you can start building the state machine. And you might be thinking, well, yeah, this is great, but I need the infrastructure, I want the code, I need the code. Well, that's good. There is a button up there that will take you to the definition. So you can download this state machine, put it in GitHub, and work as it was part of the code. And then when you want to start, this is what many teams do, they start from the workshop studio, they download this, and they don't start from a blank screen. So now imagine that you want to build this image processing workflow. You want to upload an image to S3, for example, generate a thumbnail, get some image recognition, store some metadata. You can build that with a state machine. It looks something like this. It's a state machine that executes quickly. The first step is calling a Lambda function, direct integration. We will check what kind of metadata it is. And in that process, we might check the state, the image type, if it's a JPEG or if not. If it's a JPEG, then we say, oh, if the image type is JPEG, go to the next step. If it's not a supported image type. Then we go and store that metadata in Dynamo. Again, we put into Dynamo directly. We don't need a function or a piece of compute there. It just happens automatically from the API. And then you can see in that rectangle that has these line dots, that's a parallel scenario where we are going to run two tasks at the same time. From one side, we are generating the thumbnail, and in the other side, we are doing the recognition of the images, calling an artificial intelligence service that is called Amazon Recognition that will tell us if what is in the image, if there is a lot of people looking at a person in a conference, for example. And then in the other side, we have the thumbnail creation running at the same time. That's a Lambda function that does only that. And here you could add error checks, and all that will be abstracted from the function. So if, for example, you're calling a third party to generate that thumbnail, you can do the retry on the state machine, and you don't need to do that inside the Lambda function itself. So step functions come with two integrations, the optimized integrations and the SDK integrations, and these really don't affect you that much. There is one caveat I will show you in a second. But basically, you can call any AWS service. So I want to show you 3 integration patterns that the step functions have so you can understand the power of this. So here we have a state machine that gets an object from S3, and that's a request response to S3. It requests the object, gets the object. Then it does an invoke Lambda function. It invokes the function, it gets a response from the function. This is synchronous. We are just calling those services and waiting for the response. In the case of publishing an event, this is an asynchronous request. So what will happen is we will just get an acknowledge. And this is a typical request-response flow. But sometimes we have work that takes a lot of time. So in some cases, we want to run Fargate tasks, we want to run batch processes, we want to run SageMaker models training, or things that take a lot of time. So what happens? We can use a state machine to orchestrate this. But I mentioned that the state machine can run for 1 year, and that's great. But we don't want to have the state machine on for 1 year. What we want is to stop the state machine and pause it while this other job is running. And you can achieve this with this job integration. So for example, in this case, we are running an Athena query. And Athena is just querying a S3 bucket with SQL. This can take a little bit. So while we are running the query, we are just doing the .sync in our API call, and that will pause the state machine until Athena finish, and automatically, when Athena finish, then that will resume the state machine, and we can get the results in a synchronous manner and finish our application. And what happens when we want to integrate with the AWS SDK, or with manual work, or with legacy systems? Well, then for that, we need to handle the callback ourselves. We can do the same type of workflow that we have with the .sync, but we just manage it ourselves. So imagine here, you want to have some manual worker that will press a button to confirm that something is right. So you just send this API call that will wait for a task token, and step functions will generate a task token that is some ID that you need to store and you need to preserve somewhere. When the worker, for example, press the button to confirm that a process is okay, what it will do, it just execute an API that says that the state machine is okay with the state token, and then it will resume. So the state machine will pause until the worker press the button, and then it will resume. And this is a very powerful integration to connect with manual workers, as I will show you in the demo, or with legacy systems. And it can also send failure in the same way. So that's how we can handle tasks in a controlled way. But what about how we can decouple microservices? Microservices are great. If you have been working with monoliths, you know how painful they are when you want to deploy something on Friday and some team has kind of not fixed their integration tests, or how much you need to scale your whole monolith for that 20% of the code that gets 80% of the requests. So we already agree that microservices in general are the way to go. But what happens when you have all these APIs between all these microservices that you keep on changing and touching different microservices altogether, because now you have a microservice in retail that, we are going to send an API call to the shipping so it can start the shipping, and we are also going to send a message to the notification service so it can send a confirmation, and then one day we add, okay, now we add a loyalty program, so now we need to change the retail to add that loyalty to get the points and call the loyalty program to add the point. So we keep on changing everything. And let's talk about errors in a while. And things start getting very messy and very coupled together, even if we try to decouple them. So for here is when event-driven architectures becomes our friends. We have events now. Events are signal that something changed in our system. So now we don't have these commands that is like one service telling to the other one, please send an email. And please send the points for the loyalty. Please start a shipping process. No. Now our retail, when it's ready, will send a message, hey, a customer just created an order. And then everybody will, whatever they need to do, when that happens, the retail will start, the notifications will send the notification, the shipping will start the fulfillment. Then if we add the marketing and the loyalty program, it will get the recommendations and loyalty things going on. Then we can add it to the sales report. So it's very easy to extend. It's just listening to that event and adding a new service or a new component in the place. So this makes it easier when we want to add and modify our applications. This is what it's called event choreography. We have all these different events flowing in our system. It's like music, and all those different systems are dancing to that event, and they are reacting to those events and doing things with those events. Nobody's telling me, now you need to do this, and now you need to do that. When we work with event-driven architectures, we have producers, we have a broker, and we have consumers. And usually, producers and consumers can be microservices, and they can be the same. You have the retail that may be emitting events, and also might be consuming events. The broker, what it does, it keeps the producer and the consumers totally decoupled. So the producers and the consumers don't know about each other. We have a lot of microservices that are totally ignorant of what is going on. The events are asynchronous, so nobody waits for anybody. Things are sent into space, and you trust that something will happen. And then in some cases, we need to have event stores, because some brokers don't have stores built in. So you want to have event stores just in case something failed, and you don't want to events. So in some cases, if you are calling, for example, a third-party service, you might want to put a store in the beginning, so then you keep all the events saved there, and if the third-party service is not available, then you hold those events until it's available. Or if you are working with a legacy service, you can put a store, and then the legacy service can take those events in their own pace. So here we have the producers, the consumers, and in our case, our event broker is a bus. And an event bus, what it means is just a piece of technology there that has rules. And these rules will say, okay, the orange event needs to go to the pink destination. And the blue event needs to go to the green destination. So it knows how to route every event to the right destination. So basically, it doesn't know the producer of the event, but it knows what type of events are happening, and it knows the consumer of the events. But the producers and the events, you can add the producers and the consumers, you can add them with no problem. And if you're in the AWS ecosystem, you can use Amazon Event Bridge Event Bus. This is a bus for your events that it's already built in your AWS account. So if you have an AWS account, you already have a bus. That's something that comes built in every AWS account. If you want, you can create your own buses and you can add more rules. So how Event Bus looks? Well, you have different sources. And you know that almost every AWS event either sends event to Event Bridge or sends them through CloudTrail, so they are going to end in Event Bridge, in your default event bus. So you can inspect what is going on and act on everything that is happening in your AWS account. Then you can have your own applications putting events into Event Bus, and you can act on that. And then there's many SaaS applications that can put event and Event Bridge. Then we have the event buses. I told you you already have one. That's your default event bus, where all the AWS services are sending events. But then you can create your own buses. And buses are like highways, where events are going through. And the events cannot jump from one bus to another bus. They have to stay on that bus. So buses are a very secure place where you can have your events, and other buses cannot access those buses. So if you have your application A, custom bus, those events will stay there. And inside your buses, you have rules. So those rules apply to your buses. You will say, hey, these events coming from S3 needs to go to this destination. Or these events coming from this application with this payload will need to go to this destination. And those are your destinations. You can define targets. In Event Bridge, currently we have over 20 different targets that you can define, many services, and one that is very interesting that is called API destination. Those are HTTP endpoints that you can define. So if you have third-party integrations, you can basically send events to. So how rules work? You have your sources that are emitting events. They're emitting events into the bus. And this event then will get validated and checked against all the rules that are in the bus. So this event will go and check, okay, rule 1, 2, 3, 4 million. And then it will say, okay, this event meets this rule or not. If it does, that's great. And it can meet 0 rule, 1 rule, 2 rules, all the rules. When it meets a rule, then it will get forwarded to the targets. One rule can have up to 5 targets configured. So that's a lot of propagation for one event. You can do a pretty interesting fan out here. So how an event looks, it's a JSON. It's a JSON, and it has 2 parts. The top part, what you see there, the source and detail type, and many other things that I didn't put here, is your envelope. This is defined by Event Bridge, except for the source and detail type that you can type it yourself. That's what I show in it. And then the payload is what is going from the detail down. The payload is totally up to you. So it's a JSON. It's very simple. You can define whatever you want. Then we have the rules. And the rules are also JSONs that have a very complex, that you can build very complex rules matching if you want. This is a very simple, which is matching if the currency is Australian dollars or New Zealand dollars. But you can add all kind of very interesting rules here, and I will leave you at the end of resource where you can find how to build these rules. And if this happens, this rule match. Imagine if the currency was Swedish crowns, then it will not match. But in this case, it's Australian dollars, so this event will be sent to the destination. So now we know a little bit more how to decouple these applications. Let's go to the last challenge. That is how to handle errors. Errors happens all the time. It happens within a microservice. And we have to be able to, when the car cannot be rented, go back and unbook the hotel and the flight. Or it can happen as well within a microservice, that something failed within a microservice, and we need to let other microservice know that our problem is there. So it can happen in the 2 levels, within the microservice and in between all the different microservices. So for that, it's just as easy as following the saga patterns, either if you're working with orchestration or if you're working with choreography. And this is a pattern as old as computer science. all the operations that you have that have a side effects needs to have a compensating operation. It's as easy as that. That's the error handling magic. So let's see it in action with choreography. Here we have 3 microservices and our event bus. Let's start an ordering process. So we have the order, we created a new order, we send a message to the bus and event, hey, an order is created, yay! Now the inventory service will take that, will react to that, and say, hey, I will reserve the item so nobody else can buy this thing. Great. Now we can go to the payment mechanism and say, hey, now I will take the payment. And, wow, the customer didn't have money in their account. So now we need to roll back everything that had a side effect. We need to put the item again in the system, in the inventory, so others can buy it because that item is not ready yet. And then we need to notify the customer somehow that the payment has failed and cancel that order. So this is the saga pattern. It looks very simple, and you should have it in mind in your design strategy of these things because it's very easy to forget. And then if you're in the choreography work, here's a state machine where we have to book the hotel, book the flight, and book the car. And if something fails, we need to revert it. So you can see here, when something fails, there is the compensating action already built into the state machine. So we booked the hotel, everything went well, this is a such hard word, success case. And if something fails, then we start going through the catch. And okay, this failed, now we cancel the hotel, we make sure that there is no leftovers in there, we book the flight, we make sure that we cancel the flight completely, and we cancel the hotel, and then if the car fails, then we cancel the car, cancel the flight, cancel the hotel. So it's a very simple pattern, but we tend to forget it all the time. So great, now you might be confused, orchestration, choreography, now when I use them, what are the use cases? And I will just give you a quick tip. Choreography is great between microservices. So when you have microservice 1, 2, and 3, and you want to make sure that they collaborate together. But these microservices want to be the couple, and they don't need to know each other. In this way, it's very easy to extend the application, add new functionality, modify it without affecting everybody and needing to redeploy everything. Orchestration, in the other hand, is very within your own microservice when you're the owner of everything and you need to control that sequence. You need to have that precision. You want to have that error handling. You want to have the state. You are the owner of the data. Everything is in your side. And you want to audit. So then orchestration becomes very powerful. So now you know choreography between microservices, orchestration within one microservice. And that makes it easier. Sure, there are exceptions, but these are a general rule that works. So how we design this type of applications with those concepts in mind? Well, we start from the business events. And this is a talk by itself, and there's many books on how you get these business events. So I was just imagining that you have a lovely workshop and you define those business events. And you can realize that these business events are attached to different parts of your domain. So now you put the boxes. Okay, the retail, the fulfillment, the support, all these have different events. And then within one domain, we have still many processes that we need to achieve in order to generate that event. And these processes are in order to get that event, but those can be orchestrated because usually they need to happen in a very specific sequence. There is a workflow, there is usually manual operations, or there are usually like different integrations to legacy systems or to third-party systems, and we might need to do an orchestration. That's okay. We meet that event. We put it in the word. Our broker pick it up, and then whoever needs to react to that event has a rule and say, hey, order created, I will start shipping that product. And then inside, it will have again the same orchestration for solving their own problem to emit an event afterwards. So orchestration and choreography works better together. It's not one or the other, it's both of them to make your applications more scalable, more resilient, more maintainable, and easier to work in the long run. So If you want to see this in action, because it's hard to grasp all this concept, I want to show you one example. This is Servo Espresso. I don't know if you have seen it in the Stockholm AWS Summit, but we have been all around the world nowadays. It's been 2 years since we are running this. And it's a coffee shop built with serverless technology that has, the idea is to teach you event-driven architectures. So it looks like this. Basically, we were wearing masks here because it was pandemic when we did the video, but you go, you scan a QR code. As a customer, you can pick the coffee from the menu, and then you select what you want. You create the order. That will give you an order number. There's nothing fundamentally weird here. It will appear in your screen. It will appear also in the barista application. But the magic here is that all the events are floating around. Barista then can start preparing your coffee, and the status is updating everywhere in your phone, in your screen, everywhere. When the barista is ready, then it will mark the coffee is ready to pick up. It will appear in your phone, and boom, you can pick up your coffee. Nothing special. The special part is the architecture. So that's what I want to show you. So this is something we have been running for a couple of years. We have been serving, I don't know, 100,000 drinks every week. There is 5 of these events somewhere in the world. We do around 1,000 per day. So it just works. And we have a little version now that is managed by a different team, so it runs by itself. It's quite nice. So we have these three web apps. They're built with Amplify and Vue. Nothing weird, very normal development. They're reactive, so they just take real-time events because we are using event-driven architectures. And basically, this one has a QR code that handles capacity. So this QR code can take, in general, 10 drinks every 5 minutes, and that's handled by the state machine. I will show you later. It shows you the status of the coffees, the ones that are preparing, the ones that are ready. It shows you if the store is open or closed. Then we have the ordering app, the one you have in your phone, and this shows your order, only your order. And then we have the barista app that shows all the orders, but from a different perspective. Which ones are coming in, which ones are coming in, then which ones are in production, and which ones are ready. And they have some configuration there. They can open the store, they can change the menu, and they can do a lot of different things nowadays. So this app is built on top of serverless services, Amplify, API Gateway, Dynamo, Event Bridge, and Step Functions that we talk, and I'm going to show you more about this, IoT and Lambda. There is a full session. I will leave you the link so you can see every bit and piece, because I will just cover the parts of the architecture that we are interested in. So this is the full architecture. It's a microservice architecture. We have the front ends that I show you. We have an API layer, REST APIs, WebSockets APIs to keep that effect of real time. We have events flowing between the microservices into our event router, to an event bus. And then we have an orchestration layer here that will handle the state of the coffee ordering process. And finally, we have a real-time component, but I don't have time to get into this today, but it's a very interesting use case for event-driven architectures. So this is a state machine that we have built. And I like this state machine because it's simple enough, but it's complex enough to get the good use case. So this state machine will run for every available order that we have in the coffee shop. So it will first check if the store is open. Then we'll check if we have enough capacity. I told you baristas can only do 10 coffees every 5 minutes, so that's built in there. Our baristas don't scale horizontally, so if there is lunchtime and there is 100 people wanting the coffee, they can still do 10 per 5 minutes. And then if that applies, if there is enough capacity and the store is open, then we wait for the customer to order something. That's the first pink one. And this is a manual operation. So now the customer has their app going, and it will say, hey, now you can order. And they have 5 minutes to order. If they don't order in 5 minutes, it will time out. We cannot wait for you to decide what coffee you can have. We only have 10 tokens every 5 minutes. So if you don't order in time, we will make that token free so somebody else can order it. If they order, then I generate order number, and then we put it in the barista queue. And now we can wait for the barista to prepare the coffee. So now the barista prepares the coffee, and they have 15 minutes to prepare the coffee. And this is not because baristas are lazy, it's just because they are very busy. And sometimes they forget to press that the coffee is ready. And we don't want to have these zombie orders forever running. So if a barista forgets to press the button, after 15 minutes the order will time out and will be completed. And if the barista pressed the complete order, then that would emit an event and let everybody know that the order is ready to pick up. So this is a very simple scenario, but applies very well to many scenarios that we might have in our own applications. Then let's talk about the choreography part, how we communicate between different microservices. So we have all these different microservices sending and receiving events. So that's how we drive the application. The application is driven by events, and it's a very smooth real-time application. So even though events are asynchronous, it feels extremely real-time. And then we have this choreography part. And the interesting thing here is that the state machine doesn't have business logic by itself. It doesn't do things. It just calls different microservices through events to do things for themselves. So here the state machine is just kind of controlling the state of the order itself. And then we don't have any private APIs. So this is very easy to secure. Events are private by default. So we don't have to worry about a private API, configuration authentication, or worrying about any crazy things that comes related with APIs. It's very easy. Just have events flowing into your system, handle those events, and good, you're ready. And then everything is independent. When we build this, every person in the team was working in different microservices, and we just were able to work totally independently, almost without talking to each other. I always appreciate that. And finally, we can extend this. And this is something that was very funny, because we realized we could extend this, and then we put it to test. And we built internally in Amazon and serverless espresso extensions. So now, anybody within Amazon could build their own extensions to the application. So they just have the events list, and they could do things with those events. And they will build their own microservice that will do things. And they build very interesting ones. Some of them, we are using it every day in our applications. They become part of our base code. Like we can see the average wait time, or we can see some metrics and things like that. But all of this is just extended by listening to the events that were flowing. And those events also allow us to build a test engine. So testing is one of the challenges when people think about event-driven architectures. It's hard. It's like herding cats. But what if you can add a microservice that will do all the testing for you? So we have this testing robot in place. And instead of calling the APIs externally, we just put those events into our application. And then our robot tester will generate these tests whenever we need them. And we can do them at scale. We can put many thousands of events at the same time and see what happens, how our application scales, how it works. We can do that. And these events are production events that we archive and then replay. So it's not some data that we need to create from scratch. It's real data that then we can replay later. So everything starts working together to make this service very easy to deploy and to build and to create and to extend. So you might be wondering how much this costs. I like always to show that because it's kind of crazy cheap. 1,000 drinks a day, that's more or less how much we do. It costs, if you're in the free tier, around $8. If you're not, it will be around $10 a day. And those $8 that are there, $7.98, mostly are coming from sending SMS. We send a lot of SMS to do validations, but if you do those validations through email, that is just a configuration change, it will cost you almost nothing. So that's something to have in mind when you're working with these architectures. A lot of people say, oh, this is not efficient, this is not cost efficient. Well, maybe it is. So let's sum up. Microservices are great, we know that. EDL help us to coordinate that can come from APIs. Instead of having that, let's have events. Event choreography between microservices. Event buses have rules. They help us to decouple the producers from the consumers. Adding new functionality is easy. Just look at the serverless extensions. Orchestration is great inside a microservice when you need to have that strict coordination and you need to have all this logic, but it's really not related to the function itself, but it's like those retries, those catch finally, and and maps and parallels and things like that. And don't forget your saga patterns. This is so common that people, when they're designing their architectures, they forget the compensating operations. Combine orchestration and choreography. They are not one or the other. They are the two of them. And then here you have a lot of information. So everything in here is tutorials, hands-ons, how you get started with event-rich step functions, more patterns, more EDA, more in-depth. So if you want to deep dive, just go and check that out. The link stays here in the screen. And if you need any help or any questions during your learning process, just reach out to me in LinkedIn or Twitter. I'm always happy to help you. And because we are on time, I will take questions in the outside. But I'm happy to help you.